Hi. All right, today we're just going to be finishing up the unit circle. We have filled in these parts, so let's make sure that we're good with that. The unit circle is going to have three different parts. The first part are the degrees, okay? We can always fill these in. We know that this is 0, this is 90, this is 180, this is 270, and this is 300 degrees here, right? We also know that halfway between 0 and 90 is 45. So we can then count by 45 degrees. So 90, the next one after adding 45 to 90 is 135. Adding 45 is 180. Adding 45 is 225. Adding 45 is 270. Adding 45 is 315. Adding 45 is 360. So those are all in the middle of the quadrants. And then we also counted by 30 degrees. So this is 30 degrees, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and now we're back to 360. Okay? So that was the first part that we filled out. Not on this one, but on a different paper. All right. And sorry about the size. It's the only way I could fit everything in without moving the paper all around. So sorry, it's a little awkward. All right. Next, what we did is we did radians, right? We said that this is 0, and I showed you all what a radian was. And a radian essentially is the measure of the angle when the arc length is the same as the radius. And we talked about how I demonstrated for you how they're about 3.14, just a little more than 3 radians. And we said that that was the same as pi. And that was one of our conversion factors, right? That this was pi is 180. And also that a full rotation, 360, is 2 pi. Then we talked about how if a half a circle is pi, that means that a quarter circle would be pi over 2. And there's 1 pi, and this is 1.5 pi, which is best written as 3 pi over 2. Just trust me, okay? Then we talked about what half of half a pi was, and we said that was pi fourths. So along the 45 degrees, remember that those were half of 90 degrees. So where I did the 45 degrees, we're going to count by pi fourths. So pi fourths, pi halves, that's 3/4. 4/4 is the same as 1. 5/4 is at the 225. 6/4, which is 3/2, is at the 270. 7/4 is at 315 degrees. And 8/4, which is 2 pi, is at 360 degrees. Okay. Then we talked about what that 30 degrees was 1/3 of 90. So what's 1/3 of pi half? And that's pi 6. So now we're going to count by pi 6, but we're going to simplify, okay? You have to simplify fractions. It all comes down to this, okay? So this is 1 pi 6. 30 degrees more with 2 pi 6. But 2 6 is the same as 1/3, so that's like pi thirds. 3 pi 6 is pi halves, 1/2. 4/6, well, we would reduce that to 2/3. 5/6 doesn't reduce. 6/6 is 1. 7/6 doesn't reduce. 8/6, oh, that's 4 pi over 3. 9/6 is 3 pi over 2. 10/6 is 5 pi over 3. 11/6, nothing to do there. And 12/6 is 2 pi. Okay. Notice that 2 pi has like a lot of different forms. You can think about it as 4/2. You can think about it as 4/2, as 8/4, as 12/6, like a lot of different ways that we could think about that. All right. Well, the very last thing that we talked about that the other day. All right. The other thing that we want to look at are the measures of the point, well, not the measures, the coordinates of the points. Sorry, I get nervous in the videos. We said that this is a unit circle. The unit circle means that a radius is 1. And some of the easiest points on the unit circle are the ones that are at the quadrants. We defined those the other day in the afternoon session, because I'm sure you were paying attention, as quadrantal angles, okay, when they hit the quadrants. So this whole thing, remember this radius in a unit circle, you can't see what I'm doing. The unit circle means that your radius is 1 unit, okay? So if I look back here, now I have to recenter this. If I look back here, what that means is that this, from the origin to this point, is 1, which means that this would be 1, 0. This is 0, 1. Can you see that? Since I'm going in a negative direction, this is -1, 0. And to get this point, I don't move any on the x, but I have to move down for the y. So 0, -1. Let me zoom out real quick. It's a little better. Okay. All right. So now we talked about, we also talked about different triangles. We looked at our different triangles, and what we did is we created a hypotenuse basically of 1 for all the different special triangles that existed. So what we did, I'm sorry, let me pull this out, is we drew some 30, 60, 90, a 30-degree angle, so 30, 60, 90, a 45-degree angle, and then another 30, 60, 90 focusing on the 60-degree angle. And we have like the short triangle, the medium triangle, and the tall triangle. The short triangle dealt with 30 degrees, and the x was √3/2, and the y was 1/2. So if I go to 30 degrees, it's this that's 30 degrees right here. Okay. We said that our x was √3/2, and our y was 1/2. Okay. We also said that this 30-degree angle could be in any of these quadrants. So all of these, and we did a better job of this the other day, well, I did at least, okay? All of those are the same type of triangle, they're just in different locations. That means that your x and y coordinates are always going to be √3/2 and 1/2 in that kind of a triangle, in those short triangles. But in the second quadrant, your x is negative and your y is positive. In the third quadrant, we know both x and y are negative. Remember, like back from pre-algebra, y'all learned that. And then in the fourth quadrant, x is positive, but your y is negative. So notice all those short triangles, all the triangles that are close to the axis have √3 for x, √3/2 for x, 1/2 for the y, okay? Now, the next thing we did is we looked at the 45, 45, 90 triangles. And with its 45 degrees, we said that the x was √2/2, the y was √2/2, and again, the radius, which is the hypotenuse, is 1. So I drew for you this 45, 45, 90, like a medium triangle, okay? I don't know if we want to write this. That like this right here is 30 degrees, or pi6, okay? This angle here. This angle here is 45 degrees, or pi/4. I think I'm writing too much stuff, okay? And when we have this 45-degree angle, this large one right here, okay, that we have points at √2/2 and √2/2. Once again, you could think about placing that that triangle in any of these quadrants, okay? So all of the middle points in the unit circle are going to be root 2 over 2 for x, root 2 over 2 for y. Okay. But because of the quadrant they live in, we have to give it some signs. Okay. So our x is negative in quadrant 2. Both x and y are negative in quadrant 3. And y is negative in quadrant 4. Okay. We then had another triangle. We looked at a tall triangle, which was 60 degrees, all right? When we had the 60-degree angle, so that's this big angle. Wow, this big angle here, that whole thing is 60 degrees. It's really down here, but you get what I'm saying. We said that the x was 1 over 2, and the y was root 3 over 2. That makes sense because it's taller, so the y is going to be bigger. And again, I can do that at any of these tall triangles, all of them, okay? All of those tall triangles are going to have 1/2 and root 3 over 2 as the x and y coordinates respectively, okay? But in the second quadrant, x is negative. Third quadrant, both x and y are negative. And in the fourth quadrant, y is negative. So you can see that really all you need for the unit circle is this first quadrant. And then other than that, you just kind of make things negative depending on what quadrant they live in. I want you to notice that, and this is where I want you guys to try to embrace the radians. We said that all the short triangles were this root 3 over 2, 1 over 2. Do you notice that all the short triangles have 6s in them as far as like in the radian measurements? Pi 6 is short, 5 pi 6 is short, 7 pi 6 is short, 11 pi 6 is short. That's kind of fun, isn't it? The root 2 over 2 triangles, the medium triangles, do you notice those all have 4s in the denominator in our special radian measures? And the 1/2 root 3 over 2 all have 3s in the denominator for the radian measurements. It's kind of a nice pattern, isn't it? Radian measurement might not be so bad after all, okay? And we'll talk a little bit more when I see you next time about the patterns of the unit circle. It's like beautiful, but I want you just for now, all right, I'll show you some tricks next time I see you. But just for now, we're going to evaluate the unit circle and how we I just use this unit circle as it is here, okay? And on the unit circle, what we want to remember is that our ordered pairs are always going to be in the form, this is for the whole unit circle, that remember that we said the other day that x coordinates were cosine theta and y coordinates were sine theta, okay? And to find the tangent of theta, what we do is we take y over x. So we're just going to use that idea today, okay? So how do we use the unit circle to do that, Mrs. Mackey? Well, let me tell you. So in this example, this wants us to find the sine of 135 degrees in this example. So when we think about sine, we know that sine is going to be the y coordinate. So the x is the cosine, the y coordinate is the sine. So because it wants the sine of 135, you're basically going to look at the y coordinate, okay? So we go to 135. Oh, you can't see that. We go to 135, and now you look at your y coordinate. What is it? Root 2 over 2, right? Guess what? The sine of 135 is root 2 over 2. That's it, no joke. I know, all right? What about the cosine of 210? Cosine of 210. Cosine means we're going to look at x. So my friends, you're going to go to 210 degrees on the unit circle, and you're going to look at the x coordinate. The x coordinate is negative root 3 over 2. Oh, sorry, look at x. So the x coordinate was negative root 3 over 2. So the cosine of 210 degrees is negative root 3 over 2. I swear that's it. Like, if you have the unit circle in front of you, this is great. We'll work on memorizing it next time, okay? But like this is all you do. Tangent of 60 degrees. Okay, well that's kind of a pain because tangent, we have to take y over x, okay? So tangent of 60, we're going to do y over x. So we're going to go to 60 and we're going to take y over x. So we're going to take root 3 over 2 over 1 over 2. Now, do you see that they both have over 2's? The over 2's cancel, so this is just root 3 over 1. That's just root 3, right? I was going to put an equal sign, but it is equal to that. But anyway, so that's root 3, positive root 3, not negative. Okay, sorry about my marker issue, okay? So that gives us root 3. So that's what the tangent of 60 is, just by dividing y over x. Let's keep going. Sine of 11 pi 6. Guess what we do? We're going to, sine means we look at what, guys? X or y? Oh, I don't hear anyone, just like in class. All right, during Rona. All right, we look at y. All right, so we're going to go to 11 pi 6. Find it. Look at the y. The y is negative 1/2. The sine of 11 pi 6, negative 1/2. Like, legit. That's it. What a great lesson for me to not be here for, right? Cosine of pi 4ths, I'm going to go to pi 4ths. Cosine, what do we look at? X. I guess it doesn't matter because they're the same, but I'll just make a little note that we're going to look at the x. The cosine of the x coordinate was root 2 over 2. That means that the cosine of pi 4ths is root 2 over 2. Tangent of 5 pi 4ths, we can go to 5 pi 4ths. And tangent means we do what? Y over x. So we're going to take this negative root 2 over 2 over negative root 2 over 2. So again, tangent is y over x. So that's negative root 2 over 2 over negative root 2 over 2. The two negatives cancel, turn into a positive. Those are the same, right? Doesn't that just give you 1? That's the tangent of 5 pi 4ths is positive 1. Okay. We can do the same thing for quadrantal angles. The sine of pi. The sine of pi, we're going to look at the y coordinate at pi. 0. The sine of pi is 0. How about the cosine of 0? For the cosine of 0, we're going to look at the x coordinate. So we go to 0 degrees. We look at the x coordinate is 1. The cosine of 0 degrees is 1. Like, this is it. That's how you use the unit circle to evaluate. Isn't it sweet? All right, tangent of 2 pi. Remember, tangent is y over x. So let's go to 2 pi. And so y over x is going to be 0 over 1. Is that legal? I hope you said yes, it is. 0 divided by 1 is just 0. And if we want the tangent of 270, again, tangent is y over x. So I don't have to move the paper. Do y'all see that 270 is right here and it's 0, negative 1? So y is negative 1 over 0. Okay, is that legal? I hope you said no, because anything over 0 is undefined. So sometimes you have something that's undefined, and usually at this point, that's just your tangent, okay? When we get into the other pieces, then we can do that as well, okay? One sec. Okay, sorry. So I just wanted to grab the worksheet real quick. The worksheet only has you do sine, cosine, and tangent. I want you to look at something like number 11, okay? Number 11 has, I'll zoom in. Number 11 has cosine of negative 1080 degrees. I don't see that on the unit circle. Does that mean that all hope is lost? No, my friends. Remember what we've said about coterminal angles? Like if we go an extra rotation or whatever, isn't that going to give us, like, it's going to land in the same spot? So again, I put this hint on the top that you may need to add or subtract to find a coterminal angle that lands on the original unit circle to help you evaluate. So what that means that if we have something like, oh, I don't think I want to use negative 1080. Yeah, let's not use that one. Let's use maybe 750, negative 750. Oops, you can't see that. Let's use sine of negative 750. So this isn't on the unit circle. So all I'm going to do is I'm going to use the coterminal angle. I think I used purple for that. Is when you have degrees, remember we're just going to add 360 degrees to that. So let's take negative 750 plus 360. That gives me negative 390 degrees. Okay. Okay, and I'm just dealing with the 750 right now. That's still small, isn't it? So let's add another 360, and that's negative 30. You could probably look on the unit circle if you wanted to and figure out where negative 30 is. That's super fun, okay? So if I add another 360 degrees, that gives me negative 30 degrees. But if I wanted a positive angle on the unit circle, I could add another 360 degrees, and I get 330 degrees. So the sine of negative 750 is going to be the same as the sine of 330 degrees because those are coterminal angles, you guys. And so that means that we can just look at 330. Remember, the sine means you look at y. So you go to 330 degrees and you look at y, and that's negative 1/2. So the sine of 330 would be negative 1/2. So that's legit all you've got to do. The homework worksheet for this is just having you refill in the unit circle because it's good practice for you, okay, on the front. And then on the back, it just has you doing all this evaluating. And again, you can use coterminal angles. And once you have an angle between 0 and 360, or in radians, between 0 and 2 pi, then you can go from there, okay? That being said, remember, if you have something like 17, you know I can't help myself once I start going. If you have something like 17 pi thirds, remember, like, that's not on the unit circle, that's too big. So this is too big this time, so we're going to subtract 2 pi. And so remember, like 2 pi, we want to have it with a matching denominator, so you would keep subtracting 6 pi thirds. I'm going to put a little etc., which means keep going and doing that until you get something you see on that unit circle, okay? We will talk more about the unit circle patterns next time I see you, but happy evaluating, and see if you can start getting the placement of those in your head. But we'll talk about more patterns next time. Okay, take care.